Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which converts a tree to a doubly linked list. First, let us take an example. The left and right pointers in nodes are to be used as previous and next pointers respectively in the converted doubly linked list. The order of nodes must be same as in order of the given binary tree. The first node of in-order traversal must be head node of the doubly linked list. Now, let us have a look at the algorithm. Let us also take a sample tree to test our algorithm. We call the bt to dll function with root passed as parameter. So, in the bt to dll function will point to 10. We set the previous pointer and call the fixPriv pointer function with root passed. So, in the fixPriv pointer function, root will point to 10. We have a new node pre which points to null and it is a static variable, so only one copy will be there which will be shared for all call states. Since root is not null, we call the fixPriv ptr function with roots left passed as parameter. We use a call stack for this. So, root will point to 12 which is the left child of 10. Next, we set pre to null. Since root is not null, we again call the left child of 12 which is 25. So root will point to 25. Again, since root is not null, we call the left child of 25 which is null. So root will point to null. Since root is null, the if condition doesn't get satisfied and we return to the previous call state. Now we set root's left point to pre. So 25's left will point to null which is pre. Next we set pre to root, so pre will point to 25. Now we call the right child of 25 which is null. Since root is pointing to null, we return to the previous call and finish execution for node 25. Execution for node 12 is resumed and now we set 12's left point to priv. So 12's left will point to 25. Next, we make pre equal to root. So, pre will now point to 12. Next, we call the fixPriv ptr function with 12's right child. So, now root will point to 30. Since root is not null, we pass the left child of 30 which is null. Hence, root will now point to null. As root is pointing to null, we return to the previous call state. Now we set 30's left point to priv, so 30's left will point to 12. Next, we make pre equal to root, so pre will point to 30. Now we call for the right child of 30 which is null. Since root is null, we return to the previous call state and finish execution for node 30. Also, execution for node 12 is finished. Execution for node 10 is resumed and now we set 10's left point to priv. So 10's left will point to 30. Next we set priv equal to root, so priv will point to 10. Now we call the right child of 10 which is 15. So now root will point to 15. Since root is not null, we call for the left child of 36 which is 36. Hence root will point to 36. Since root is not null, we pass the left child of 36 which is null. Since root is pointing to null, we return to the previous call state. We set root's left point to pre, hence 36 left will point to 10. Now we make pre point to root, so pre points to 36. Next, we pass the right child of 36 which is null, hence root will point to null. Since root is pointing to null, we return to the previous call and finish execution for node 36. Next, we set 15's left point to pre and we make pre equal to root. Next, we call for the right child of 15 which is null. Since root is pointing to null, we return to the previous call state and finish execution for node 15. Also, execution for node 10 is finished. We return to the bt to dll function and now set the next pointer and return head of the doubly linked list. So we call the fix next ptr function with root passed. Now we have priv which points to null. Since root is not null and root's right is not null, we set root to root's right. Hence root points to 15. Now we start from the rightmost node and traverse back using left pointers. Since root is not null and root's left is not null, in the second while loop we set priv point to root. Next we make root point to root's left, so root will be equal to 36. Now root's right will point to priv, hence 36 right will point to 15. Since root is not null and 36 left is also not null, we continue with the while loop. Now we make priv point to root. Next we make root point to root's left. Now we had set 30's left to 10, so root will point to 10. Next we make root's right point to priv, so 10's right will point to 36. We continue with the while loop as root is not null and 12's left is also not null. So now priv will point to 10. Also we make root point to root's left. We had set 10's left to 30. Hence root will point to 30. Now we make root's right point to priv. So 30's right will point to 10. Since root is not null and 30's left is also not null, we make priv equal to root. Next we make root point to root's left, which is 12. Now root's right is set to priv, so 12's right is 30. Since root is not null and 12's left is not null, we set priv point to root. Now we make root point to root's left, hence root points to 25. Now 25's right point to priv. Since root is not null but 25's left is null, we come out of the while loop and return root, which is 25. We have the final double linked list. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.